Alright, so let's take a look at an example of how to calculate slope. And we're going to do it with a snippet of terrain. So it's going to be in contour form. So example 1, we want to know how far apart must the contours be in order to achieve a 4% slope. So here's our example snippet terrain. We see here our contour information. So step 0, we need to study our given. So we want to make sure there's no hidden information. There's nothing really hidden here. Step 1, we want to make a diagram. So we want to show our knowns and unknowns. So we know that the change in z is going to be 6 because 306 minus 300 is 6. So we're basically taking the high point, which is 306, minus the low point, which is 300, which yields the value 6. And to show this in clean math, this is how we would do it. We would do slope equals 4%. So right now what we're doing is we're listing our knowns and our unknowns. And we want to also indicate what our unknowns are. So we don't know what the change in x is. But we can find the change in z by taking the high point minus the low point, which yields 306 minus 300 equals 6. So this is the clean math form of this. This very clearly shows you, or in this example here, it clearly defines what your variables are and how you came about the number 6 for the change in z. Since it doesn't exactly say here, you get to derive that from doing just a little bit of math. Step 2, now we want to set up our equation. So to do this, we want to state the equation that we're going to be using, and we want to use the generic form of the equation first, and then the version that is going to be using our variables. And we want to do this because, again, we want to make sure the person who's going to be checking our math is going to be able to understand where we are pulling our variables from, kind of like where the numbers come from. So clean math example here. So generically, slope equals rise over run. Slope equals the change in z over change of x. So those are our defined variables here. So step 3, we want to plug in and solve. So again, first plug in before solving. And if you think it may not be obvious how the problem was solved, you can state and show intermediate steps. So again, we're kind of just rewriting the equation, but we're plugging in our numbers. So we're using the slope equals rise over run. So that's 4% equals 6 divided by x, and we added the times 100 here since we want to get rid of the decimal value. And then the next step, we can actually show the answer. So if we needed to, we could add intermediate steps in between here if you think the person who's checking your math might not be able to get it.